Hello and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich from Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, Captivate, or wherever you get your podcasts. So in our last episode, we talked with Anthony McRae from Danfoss about the trends facing the data center industry and the outlook on data center sustainability over the next 5 years. Today, we're going to do a deep dive into the challenges in building carbon neutral data centers with Dick Lord, our senior fellow at Carey Corporation and an ASHRAE Fellow who's been involved in writing data center standards like ASHRAE 90.4. So if you've been in our industry for any amount of time, you've probably either run into Dick or certainly been impacted by the standards that he's helped put together. So, Dick, thanks for taking the time to join the show.
Sure, glad to be here.
So first, maybe can you tell us about your role, or maybe I should really say roles, in ASHRAE and the work you're doing in setting standards for high-performance buildings and how that includes the data center industry, and maybe how are those standards evolving and what's that going to mean for our industry going forward?
Yeah, I've been involved in ASHRAE probably going on almost 30 years now. One of the committees I'm involved in and have moved up to the ranks on is ASHRAE 90.1, which is the efficiency standard for commercial buildings. I'm currently the chair of that committee. It's an interesting committee. It's a committee of about 50 voting members, and then we have another 50 consultants. So there's about 100 people on this committee, and very, very active committee. We meet probably 4 times a year for 3 days, and a lot of weekly, monthly conference calls. But, one of the challenges we faced in 90.1 when I took it over, it has definite energy efficiency improvement goals. So each 3-year cycle, we set a goal as to how much energy efficiency we were going to improve. And I kind of anticipated that I might get challenged when I took over this chair. And lo and behold, I got challenged by the leadership of ASHRAE as, hey, how can we get this standard to carbon neutral by 2030? And I said, well, hey, can we have 3 code cycles? Can I get there by 2031? And so we have a work plan that lays out how to get to what we call net zero operational carbon neutral. So that's for a new building. How do you get that building to be carbon neutral? Which is a real challenge. It's going to require about another 20% efficiency improvement and about 35% use of renewable energy. So 90.1, as I'm describing, is commercial buildings. There also is a standard called 90.4. And 90.1 and 90.4 work very closely together. 90.4 is for data centers, and we actually have a defined requirement for data centers. It gets into a watt density in the room. In a lot of commercial buildings, there's also what they call computer rooms. So the 2 committees work pretty close together. And 90.4 covers the large data centers that you see around the world now. It's on kind of the same schedule, updated every 3 years, and we work back and forth together pretty closely with those 2 standards. And I was involved a lot with the 90.4 when it was first developed.
When we first were looking at efficiency standards, right? I mean, we started with the basics, EER, right? Just make a motor run more efficient. And then we kind of said, well, that's kind of nice, but you never really run at those conditions. So we're going to have like an SEER or IPLV, and we're going to make sure that the motor runs across a range, and then that unit, the chiller or rooftop or whatever it is, runs across that range. It's really impressive when you look over time how now, right, ASHRAE, we're looking at really the whole building, right? And it's not just anymore this fan, this valve, this pump, this whatever. We're really looking at the whole building. And I think it goes to show, too, how far we've really pushed the technology. You're not going to get 30% more efficient out of a compressor or chiller or something like that, right? We really have to start thinking systems. And it's super interesting, I think, that we have those, now really at the building, and then even building subsections like data centers that we're really looking to make those as efficient as we can. I think that's, when you look in hindsight, we've really come quite a long way, I think, within ASHRAE.
I hate to tell you this, but, a lot of those metrics, actually, I'm the guy that developed them. So, like IER, IPLV, we developed all those, and we're moving on to the next generation of them now. It's things you'll hear, metrics like IVEC and IVHE and SCORE and SHORE. And one that I really like is a metric called TSPR, Total System Performance Ratio, because as you noted, you can only make a chiller so much bigger and add so much heat transfer. And there's a thing I try and educate people on, which is the second law, thermodynamics. But I tried to explain that to Congress one time, and they didn't really understand it. But, a lot of things we're looking at. So we're trying to look at the system. So, you take a chill water system, which is often used on a data center. Well, it's got pumps, it's got cooling towers. They all use a lot of energy. And lo and behold, pumps use a lot of energy because they run all the time. So we're trying to look at things like, hey, how do we reduce pump energy? And, one of the approaches was, hey, do we really need to run a 10-degree delta T, or do we do a 15-degree delta T or a 20-degree delta T? And so we've done things like that. And a lot of things we're looking at now are what we call annualized metrics, where, you design it for the 95-degree day or that peak day that we see in the middle of the summer. But now we're looking at annualized. And one of the key things they're looking at a lot on data centers is data centers run year round. So in the middle of the winter, do you really need to run that chiller? No, you don't. You can free cool it. And so a lot of data centers now have options for free cooling integrated with the chillers, or they do hydronic free cooling. And there's a metric that we developed for data centers called PUE, and it's the ratio of cooling total energy to IT energy. So if you get to a PUE of 1, that means you're not spending any energy to cool that data center. And so, a lot of people are getting down in the 1.1s, 1.05s. A lot of times you can do that very easily in a cold climate, but there's a reason data centers are where they are because they like the infrastructure. So, a lot of new metrics, a lot of new approaches. A lot of what we try and do is actual modeling of data centers, including CFD analysis of airflow inside data centers, and a lot of technology being employed to help keep them cool.
Yeah, absolutely. So you brought up a good point on that cooling load that's going up, and something at least I hadn't realized so much in my discussion last time with Anthony is how much more energy AI is taking, right, and machine learning and all that kind of stuff. And last time I had mentioned, right, that a Google search versus an AI search, right, it's 10 times more energy doing an AI search, Google AI search, than it is to do just a standard Google search. And it's something we do ubiquitously, right? I mean, you do it your phone I won't say at a red light, right? But you do it on your phone, right? Sitting in a waiting room or whatever it is, and you don't even think about it, all this energy that we're using. So this growth of AI, right, and machine learning, it's having a huge impact on data centers. Can you maybe talk a bit more in detail on what kind of implications that's going to have for our decarbonization goals?
Sure. To give you a rough feel, is the U.S., about 3% of the national electricity goes to run data centers. That's a big number when you think about it. By 2030, they expect it to grow to about 8%. So it's going to pretty much triple. And the reason is when you do AI, they tend to go to graphics chips. And graphics chips are a lot more energy intensive. Like we're looking at it, in my company, we're looking at how do you cool those chips. And chips now run in the order of about 50 watts to 100 watts. By 2050, they're expecting to hit about 2,500 watts per chip, which it's not only going to increase the cooling load of data centers, it's going to change the way we cool those chips. One of the things that you look at for data centers, if you go into a data center, they're primarily all air cooled. So they'll have chiller cooling coils, and then they have what they call fan walls that blow a lot of air across the servers. And that's pretty much reached the technology limit. And so, you're going to start to see the data center industry evolve to liquid cooled. And liquid cooled would be water. It could be other fluids that don't change phase. And, if any of you are into the gaming computers, if you look at a gaming computer today, which is very graphics and intensive, a lot of them are water cooled. So you're going to see data centers evolving from air cooled to liquid cooled, and you'll see hybrids in there. You might see part of the server cooled with air, part of it cooled with liquid, and it'll keep evolving. And we get a lot of requests from data centers is, hey, how can I boost my capacity without total redesign of my data center? But then, you're going to reach a limit where even water, a single phase fluid, won't keep that chip cool. And then you're going to look at two-phase things. And this is like the refrigerants we use in our air conditioning equipment, where it comes in and it changes phases like boiling water. And you're going to see what they call direct-to-chip type cooling, where you circulate refrigerant directly to a chip, or you're going to see a data center where the whole board is immersed in boiling refrigerant. They call it immersion cooling. So there's a lot of technology being developed right now that, if you go to shows like OCP where they advertise or they show all the new data center equipment, you'll see a lot of this technology. And the one thing I'll note about data centers, I grew up in the HVAC industry. We're a relatively moderately moving industry. Data centers are much, much faster. The average life of a data center, 5 years. The computer's, then done and they go to the next computer. Think how long do you keep your computer? How long do you keep your phone? Not very long.
Compared to how long you keep your, residential air conditioning unit, right?
Yeah, like 15, 20 years for residential air conditioning. Yeah, they're much, much quicker. And a typical data center, like we had a customer, asking, he's buying 23,000 ton chillers to cool his data center. It's a lot of capacity. And,
it's a lot of chillers.
Yeah, it's a lot of chillers, a lot of cooling. And, data centers tend to run pretty much flat out all the time. You mentioned Google searches. It was actually interesting in our company. We just trained everybody on AI searches. And then everybody says, hey, the internet's really slow.
Yeah.
It's because everybody's searching.
So maybe I'll stay on the topic of the cooling technology. So we talked about air-cooled, water-cooled, which is, basically you've got a mini heat exchanger on every chip, and then we're doing heat transfer on the chip, right? Because sometimes people will call it liquid cooling, but you're not submersing it right in that case, and then the immersion cooling. But you mentioned also refrigerant. So I guess you're going to use a mini evaporator, if you will, on each chip and then do that to remove the heat. Is that the idea there?
What you actually do is you take the chip and you put it on like a copper substrate, and then you liquid cool that substrate, and you actually keep that chip, or you'll put a cover over the chip and you'll circulate boiling refrigerant around it, keeping the chip cool. So it's like a little mini heat exchanger on each chip inside the server. If you were to look at a back of most data centers have what they call racks, and you'll see 30, 35 boards in a rack. There'll be a whole bunch of hoses and fittings feeding liquid refrigerant to each one of those boards. Typically, a board will have 2 chips on it, so you're keeping both of those cool. And it's not just the chips too. All the communications hardware, all the memory on there, all generates heat. So you've got to keep all of that cool.
Is that how you see the end game if we get to these super high power consumption on all those chips? Is the end game, what do you think? Is it immersion? Is it refrigerant to chip? Or maybe it's it depends kind of answer?
It depends right now. There's 2 types of data centers. There's multiple types. There's the colo data centers where, you may go in and say, I'm going to lease an aisle and I'm going to run my stuff in it. Starbucks or somebody like that may lease an aisle and they use it for their computing, or it could be an airline or things like that. And then there's the Bitcom data centers, which are very dedicated ones, or a Google data center, which is handling all of their orders. Some of them may go full immersion. The full immersion, kind of picture it this way. It's kind of like a little mini refrigerator or freezer that sits horizontally and it's full of boiling refrigerant or a phase change material with a cover on it. Most data centers tend to be vertically oriented, so they have a rack of a slide in a server and a slide in a computer board. The ones where the slide in, they may go more with the direct-to-chip, although it's an interesting time. You see a lot of new technology coming out. I've seen full immersion ones. I've seen direct-to-chip. I've seen little mini, think of it this way, like I got a little mini cooler that I plug into a rack, and it's got a cover on it, and it's full of boiling refrigerant. So the answer is we don't know yet. So everybody's developing this technology. A lot of startup companies involved in this. People in our business, the air conditioning business, forming relationships with data center companies, with computer companies. It's a very interesting time to see where the technology is going to go.
Yeah, I draw a lot of parallels to the HVAC industry, right? We're going through this refrigerant transition, and there's no perfect answer, right? We have to balance safety, flammability, toxicity, pressure, right? And all those things to get the right solution. And it kind of sounds the same with the data centers, right? Water and electronics don't necessarily mix well, right? Refrigerants in the system, immersion cooling. There's so many different things. Nothing is jumping out as the perfect one. And it's just a matter of...
Yeah, it's interesting when you look at like the liquid cool where they're using water. They're very sensitive about water leaks. So if you look in a server rack, you'll see little wires running along all the water tubes. Those are leak detection circuits. And then some people like to run their water loops at negative pressure. So if I get a water leak, I leak air and I don't leak water out because, like you said, water and electronics don't mix very well together. So they have a lot of technology. They have what they call CDUs, which isolates the server water loop from the chill water loop so that you're not going to dump all that water into a server. And yeah, there's a lot of technology being developed. It's interesting because you are working with electronics people, with computing people. So as far as software and logic, that's a big deal to them too. So automatic diagnostics, automatic monitoring. There's companies that are setting up that basically monitor the data center and take care of all the diagnostics and prognostics and service. And
Right. Yeah, I guess I probably digressed maybe a little bit. It's super interesting to get into the technical weeds, but maybe if we take one step back here a little bit and talk about the data centers themselves. So Danfoss, we've recently published a paper on data centers that looked at crucial issues like community reluctance to build data centers, kind of the NIMBY effect there, right? And grid readiness, costs, all that kind of stuff. And one of the biggest concerns with the growth is grid stability, particularly if we want to reach full electrification. So how is the grid evolving, and what additional technologies do you think are going to be needed to support a sustainable data center?
When I first got involved in data centers, why aren't all the data centers in the north where it's cold? Why aren't they near the power plants? Well, a lot of it comes down to the infrastructure for communication. So they want to be where there's fiber optic communications lines. So if you go north of Washington, there's a data center community there. So they went there and they put the infrastructure in for power, the infrastructure for communication. But, just a couple of months ago, that data center quarters reached max capacity. They can't get any more electricity. And it's a fairly populated area. You talk to some homeowners and do I really want a data center in my backyard? I mean, they're not a bad looking building. They tend to have no windows and 3-4 stories high.
No smokestacks.
No smokestacks. No pollution coming out of them.
Yeah.
But it's interesting. They're trying to figure out where do we put data centers? How do we get the infrastructure? Some data centers are now saying, let's put our own infrastructure and let's put our own power plant in. Like I think it was one of the Danfoss symposiums. We had a guy talk about a data center he's putting in downtown Chicago, and what he did is he said, I'm going to put it in downtown Chicago. Got an agreement with the government to put it there, which building permits are tough to get. But then he put in his own power plant, and then he set it up where the waste heat from the power plant and the waste heat from the data center, they're going to use to heat the buildings around them. So it's almost like you need a planned community when you look at a data center, because we're probably going to get into it, but when you want to get a data center to be green, you're never going to get it to be work totally from renewable energy. You've got to exchange some of the energy with other communities, and we're doing more of that in Europe right now. That's pretty common over there. But yeah, people resist data centers coming into their area. Just they're worried about, does my tax rate go up? Does my, do I have more cars going up and down the roads and things like that?
You bring up a really good point on that heat reclaim or heat reuse. And here in the U.S., I guess, I don't know, maybe other than kind of in the Northeast in general, we're a pretty spread out country. So not a whole lot of opportunities to do like a district heating loop. And typically, I think we do lots more district cooling than district heating here in the U.S., whereas in Europe, lots of district heating and they can tap into those systems. But you're saying, so there is some, I don't know if Chicago has district heat or not.
Yeah, Chicago has some district loops. If you look at Baltimore, that has a district loop in it. You look at, I grew up in Syracuse, New York. There's a district heating and cooling plant to serve all the hospitals. Universities are a good choice for district heating and cooling. You're right, in Europe, they're a lot more common. Like we put a data center in Switzerland, and we're heating the whole city with the data center. There's more than enough heat to do that. You got to be careful. U.S. tends to be a warmer climate zone, so, you don't need a lot of heat in Miami, where, if you go to Canada, you do. But now people are starting to look at, well, can I use that waste heat for a process? Can I do a desalination plant? Can I do an agricultural facility? And another trend, and we won't get into it here, but is indoor growing facilities. There's a lot of benefit to those, and a lot of times they will need heat. So it gets into a lot of community planning, which is difficult to do because it's hard to get a building permit for a community.
Right. Yeah.
You get a building permit for a site.
Yeah, just as kind of, we talked before, right? Looking at from efficiency of motors now to efficiency of buildings, you kind of have to do the same here. It's not just what are you going to do with the heat at that data center, but is there a indoor facility? Is there a university or a hospital? And suddenly you have to talk with somebody who doesn't care about data centers. They care about hospitals, right? And that stuff. So
yeah, and we've had those discussions, like we said, hey, we've got excess heat, we can give it to you. The guy goes, well, I'll take it free. Well, the data center doesn't want to give it away free. So you got to get into contracts and things like that. It's a lot easier, when you go in places like China and the Middle East, they'll build a whole city. So when you build a whole city, you can start from scratch and put the infrastructure in to do it. Don't get me wrong. There's, I think in New York State, there's 28 district heating cooling projects underway right now. So there's more and more of them coming.
Yeah, it's a whole different mindset now than just, you have to think a little bit more about where can I buy the acreage, right, and get it to work. So yeah, I think that's a challenge we'll see going forward for sure. If we come back maybe now down to let's say the system level, what kind of challenges are the OEMs facing to help data centers become more carbon neutral?
It's looking at the whole system. So like, one of the things we're doing in my company right now is actually having a software development to look to end-to-end calculations of energy, because if you look at a data center, there's a lot of heat transfer. You go from the air to a chiller, you go to a CDU, sometimes there's 3 and 4 heat transfers in there, and you got to try and minimize all those things. You've got to try and do things as, can I use more free cooling? So, hey, do I need 60 degree F water to cool a chip, or can I do it with 80 degree F water? If it's 80 degree F water, now I can do a lot more free cooling because a lot of days it's much cooler than that. One of the ones we've had a real challenge with is, if everybody's familiar with evaporative cooling, you can get a lot cooler water temperature like the cooling tower if you evaporate water. But a lot of people are concerned about water use these days. So a lot of data centers, well, I don't want to use any water. But lo and behold, when you look at the complete system, look at most power plants, they reject their heat through cooling towers. So it's where to use the water. So we're looking at those. Can we use evaporative cooling? Can we improve evaporative cooling technology? How do we use more free cooling? Like we said, what do we do with the waste heat? What do we do with the temperatures that we have to cool the chips with? Can we get better heat transfer so it doesn't take as cold of water? Well, one more thing, maybe just to go back is, when we're doing the air cool, one of the things they try to do is they had what they call hot aisle, cold aisle. They'd raise the temperatures really high so they could do more free cooling. We're going to have to do the same thing with liquid cooling.
Right. Data centers have a WUE also, right? I mean, where they're measuring the efficiency of their water usage also, right? But I think there's also maybe some, say, gaming of that system that favors some solutions. But yeah, at least it's good that it's all getting measured, right? Especially if you're out in the Southwest, you don't want to be using tons of water.
Well, yeah, and part of the problem, like I was just reading an article yesterday, they said we're kind of taking way too much water out of the Colorado River. So it's, it's going down, and it's water conservation. There's new cooling power technology that says, hey, I can use 80% less water, because when it gets cold out, you don't need to evaporate water. So you shut off the water. And the big thing people don't like about water use too is there's maintenance, because, you have cooling tower fouling and a lot of things that you have to do to maintain data centers.
Yeah, and the scaling and all that kind of stuff, right? Water just adds to the complexity.
It's another thing, yeah. I mean, if you look in the world, electricity is one of the biggest issues, but water use is probably number 2.
Yeah, I'm not sure which concern is growing faster, water or electricity, but both of them are going to become more and more important in the future, right? And so now if we take even one step further down, how can suppliers, people like Danfoss and the OEMs work together so that we can get this carbon neutral data centers?
A lot of it takes collaborative effort. So like, we've had a lot of joint sessions with co-location data centers. We've got together and had brainstorming sessions. I know Danfoss has been really good at symposiums where it's not just Danfoss people, but it's everybody from the industry saying, hey, here's something I did. Here's a technology I developed. Here's an approach we did. And so, I think the industry is doing a lot. There's also, in the U.S., we have, I think it's 16 national labs. So the national labs, Oak Ridge, NRail, Argonne, they're all getting into data center cooling. So right now, I do know, I live not too far from Oak Ridge National Lab. They're building a data center test facility, so we can go there and experiment on data center cooling technology. And like I said earlier, this market moves really fast, so we have to respond very quickly. normal development time, like on a Carrier product or a Danfoss product, would be 3 to 5 years. Data centers, well, I need it in a year. How can you do it much, much quicker?
I had a phone call with somebody today, and I asked, would they be interested in new product development? And they said, yeah, no problem, as long as it's ready by 2026.
Yeah.
Right. So, yeah.
Yeah. I mean, to give you a feel, data centers have bought out the generating capacity in the world for the next 5 years. If you think of a data center, they do not want to shut down. So if the grid goes down, they have generators that come back online almost immediately.
Yeah. I think you nailed that one word, collaboration. Whether it's at the super high level, the data center collaborating with, let's call it the town, the municipality, the hospitals, universities, right? You can't just design a data center without looking at that. Or if it's the data center guys working with the OEMs on the component level, you've got to work together to optimize it. And then the same, right? The OEM working with the component suppliers to optimize the systems. You can't lock yourself in a room anymore, right?
It's not even just that. It's like when we started to regulate data centers, all the data centers guys came into the room and said, we're mission critical. Just leave us alone. We know what we're doing. And over time, we developed a relationship, and then, we developed the PUEs, and it got to be where you got to know each other and you collaborated. And the data center community actually has an open meeting once a month where they come in and they share new technology. And, you can sit there and one data center, well, hey, I tried this and this worked, or I tried this and it didn't work. So kind of an interesting time that you wouldn't have seen probably 20 years ago.
Right. And 20 years ago, you designed your widget, threw it over the wall to the guy that you wanted to sell it to, and then, they could take it or not. So, yeah, for sure, interesting times with the collaboration. Maybe then before wrapping up, was there something I forgot to ask you wanted to mention before we close out?
It's a collaboration, trying to look at how we can optimize this. I mean, there will be a lot of new technology, the chips continue to evolve. They evolve very quickly. One of the hotbeds for technology is Houston, Texas. That's where a lot of the data center guys are located. But there's also, like Arlington University in Texas, they do a lot of fundamental research. How can we effectively cool that chip? What kind of heat transfer do we get? So there's actually fundamental research facilities popping up, developing technology, and seeing where it goes, really.
Mm-hmm. Yeah. And then maybe make a plug for ASHRAE, AHRI, and the organizations. So for everybody out there, if you're not members, at least consider it, I think. And you can see there's all these standards are being developed. And so when you wake up one day, whether you're doing the installations or you're doing the design work and wondering, why the heck do I got to do it this way now? Usually starts somewhere at AHRI or ASHRAE. So join up, become a member, and have your input. Yeah.
A little plug for that. I'm an ASHRAE Fellow, but
yep.
And I was actually nominated by a competitor, which was interesting. But ASHRAE is a great organization. So when you go to these meetings, they're very long meetings, typically 12 hours long. But everybody in that room is probably the sharpest people you could find in the industry. So if you have a question on Sunday morning, I can get an answer from a guy in California. And people there tend to be, they're very energy conscious, they're very environmental conscious, and it's a great place to learn. And I'd say not even just the national meetings, that are twice a year. Go to your local chapter, and every meeting they have a guy like me or somebody else give a presentation on something they're doing. You can learn a lot and meet a lot of very smart people.
And it gives you the chance, one, to know what's happening before it hits your desk and you have to implement it. And two, gives you the ability to influence, right, if you're so interested, right, on things that are coming down the pike. So fantastic.
Yep.
Great. Well, I appreciate it. Thanks, Dick. That's it for this episode of EnVisioneering Exchange. And I'd like to thank my guest, Dick Lord from Carrier Corporation, for joining us.
All right. Thanks, everybody.
Don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, Captivate, or wherever you listen to podcasts. And lastly, if you enjoyed this episode, don't forget to rate, review, and share with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.